Every day, use your time like a weapon, like a tool, like a springboard. Spend time to make yourself better, and the world will become better with you. Don't get me wrong, enjoy life, but don't over celebrate your average life. Work hard now so that you can rest later, and don't rest now and suffer later. And always remember that while you're partying, many are preparing. And let's get into today's video on chi-square test of goodness. So, in my earlier video, I have explained you about the concept, and in today's video, I'm going to explain few problems which are very important. Let's get into today's example. That is, the number of automobile accidents per week in a certain community are as follows: 12, 8, 22, 14, 10, 15, 6, 9, 4. Are these frequencies in agreement with the belief that the accident conditions were the same during the 10-week period? See here in the solution, here, the number of automobile accidents per week in a certain community are as follows. So, these are all the accidents per week. And here, the expected frequency of the accident per each week is. So, we have to add up all these. Expected frequency is nothing but the average. So after adding all these values, we got 100 divided by the number of accidents 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10, which is equal to 10. So we got the expected frequency as 10. And now we have 5 steps here. First one is, as usual, null hypothesis. The accident conditions were the same during the 10-week period. Alternate hypothesis. The accident conditions are different during the 10-week period. So we have to take the alternate statement. And next one, this is the table here, the observed values. See, these are all the observed values, the accident per week, that is 12, 8, 22, 14, 10, 15, 6, 9, 4. So we have to fill up in the first column, and the next one is, this is the expected frequency. The expected frequency is also we have calculated, which is equal to 10. So this is 10 in the second column. So we have to make a subtraction, that is 12 minus 10 is 2, and 8 minus 10 is minus 2, 20 minus 10 is 10, and 2 minus 10 is minus 8. So we have to fill this column like this. So for finding the chi-square test, this is the formula, that is OI minus EI whole square by EI. OI is nothing but the observed frequency minus the expected frequency. This is the table here. So we have to make the square, that is 2 square divided by, again, the expected frequency 10. That is 4 by 10, which is equal to 0.4. And the next one is minus 2 square divided by 10. That is 0.4. 10 square divided by 10, which is equal to 10, minus 8 whole square divided by 10, the value here is 6.4. 4 square divided by 10, that is 1.6. So we have to fill this column, and after making addition, we got the value as 26.6. Clear? So first one is observed value. So we have to make an expected frequency. We have to take the average. When we have to subtract it, we have to make a square and divide it by EI. And next one, see here, for chi-square test of goodness, this is the formula here. That is a sigma OI minus EI whole square divided by E. The value we got as 26.6. So now the calculated value of chi-square is 26.6. Clear? And now we have to go to the table and we have to check the table value. If the level of significance is not given, see here, please remember, so the calculated value here is 26.6 here, and here n value is equal to the number of observations are 10, degrees of freedom is equal to n minus 1, which is equal to 10 minus 1, which is equal to 9. So in the table, see here, chi-square, the critical values of chi-square distribution with v degrees of freedom. See here, the degrees of freedom is n minus 1, that is 10 minus 1, 9 at 5% level of significance. See, at 5% level of significance, the value here is a 16.919. So here the tabular value, so here this is the tabular value, that is 16.9. So this is the calculated value. So it is very clear that the calculated value is greater than the tabular value. So it is very clear that the calculated value is greater than the tabular value, and therefore the null hypothesis, we have to reject the null hypothesis. And the conclusion part here is, and conclude that the accident conditions were not same during the 10-week period. And this is how we have to solve. This is so simple. If you observe the table, the observed values and the expected values, so the formula is also very simple, that is sigma OI minus EI whole square by EI. So that is the calculated value. So after comparing the calculated value with the tabular value, so if it is greater, calculated value is greater than the tabular value, we reject. If it is smaller, we have to accept it. So let's get into the second question here. A sample analysis of the examination results of 500 students were made. It was found that 220 had failed and 170, see here, 170 secured the third class. 170 has secured the third class and 90 were passed in the second class. So see here the data here. The 90 were passed in the second class and 20 got the first class. So out of 500 students, 200 students failed, 170 got third class, 90 got second class and 20 got the first class. Do these figures commensurate with the general examination results, which are in the ratio 4 is to 3 is to 2 is to 1 for the various categories respectively? See, as usual, we have to go with the null hypothesis. So here the null hypothesis is the observed results commensurate with the general examination results. And the next one is the expected frequency are in the ratio. Which is the ratio? What is the ratio here? 4 is to 3 is to 2 is to 1. So this is the ratio given. And the total frequency here is for 500 students. The total frequency 500 students. We have to divide the total frequency 500 in the ratio. That is 4 is to 3 is to 2 is to 1. See here the total ratio here is 5 plus 5, 10. 10 here. For the first ratio here, 1 by 10 into 500. Clear? So if I cancel, this will be 50. For the second one, this is 2 by 10 into 500. So if I cancel this one, so this will be 100. This will be 100. Likewise, this is 3 by 100 into 500. So if I cancel zeros, so this is 3 5 15, that is 150. And next one is 4 divided by 100 into, the total here is 500. The total here is 500. So if I cancel here, see here, the total ratio here is 10, only 10 here. So if I cancel 110 out of 500, so we are getting 500. So there is only 110 here. If I cancel 10, so this will be 200. See, so this is the expected frequencies which are in the ratio. The expected values are 50, 100, 150 and 200 here. And if we divide the total frequency 500 in the ratio, we are getting 200, 150, 100 and 50 like this. So the total ratio is 10 and here the total frequency is 500. That is the first ratio is 1 by 10 into 550 and 2 by 10 into 500 which is 100 and 3 by 10 into 500 which is 150 and 4 by 10 into 500 which is equal to 200 here. So here, so we have calculation for chi-square. So for chi-square, the class here is the first class, third class, second class and first class. The failed candidates here are, see here how many are failed here? 220. The 220 are failed and 170 got the third class and the next one 90 got second class and 20 got the first class. So these are all the observed values and the expected values here are 200. See here 200, 200, 150, 100 and 50. So we have to post it in the third row. And next one we have to make a subtraction, that is 220 minus 200 is 20, 170 minus 150 is 20, 90 minus 100 is minus 10, 20 minus 50 is minus 30 divided by expected value. So what is the expected value? The expected value is 200 and let me see, that is 220 square. So we have to make the square out of this and let me show you and see. This is, if you make a square, so this will be 20 square 400 divided by the expected value here is 200. The value here is 2. Clear? And the next one here is again 20 square divided by here. Now the expected value is 150. The value here is 2.667. Like that we have to fill this column. So we have to make the squares and divide it with the expected value. So this will be the expected value, and therefore after making addition, so this is 23.667. So you can use your calci while solving all these, and here the calculated value is very clear as 23.667. Now the degrees of freedom. So n is equal to 1, 2, 3, 4. So here the for degrees of freedom the value here is n minus 1, that is 4 minus 1, 3. The degrees of freedom here is 3. For chi-square, so we have to go with the table and check with 3 at 5% level of significance. See, at 5% level of significance, the value here is, see, for the chi-square table, so here at 3 degrees of freedom, so we have to go with 5% level, that is 7.815. This is a 7 point at 3 degrees of freedom, the value here is 7.815. Now we have to compare. This is the calculated value and this is the tabular value. So here the calculated value is very greater than, so here it is greater than the tabular value, and therefore we are going to reject the hypothesis. So now we are going to reject the null hypothesis, and therefore the observed results are not commensurate with the general examination results. And this is how we have to solve. So this is also very clear that out of 500 students, 220 failed, and 170 secured third class, 90 secured second class, and 20 got first class. And the expected values are in the ratio 4:3:2:1. So this is the way we have to calculate the expected values, and these are the observed values. So we have to make a subtraction, and this is the formula, and after making an addition out of this, so we have to go with the table and we have to compare the expected value, the calculated value and the tabular value. So here the calculated value is strictly greater than the tabular value, and therefore we reject it. And the next question here is the third question. See here, the following figures show that the distribution of the digits in numbers chosen at a random from a telephone directory. So these are the digits and these are the frequency values. So test whether, so we have to test whether the digits may be taken to occur equally frequently in the directory. So equally frequently. So again, in the solution null hypothesis, the digit occur equally frequently in the directory, and alternate hypothesis, the digit do not occur equally frequently. Under this null hypothesis, the expected frequencies for each of the digits are, this is 10,000 by 10. See here how many numbers are there: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I make an addition, this is definitely, this is 10,000. So the value here is 10,000. So the expected value here is the mean value, that is 10,000 by 10, which is equal to 1,000. So here I am putting it in a table for calculating the chi-square value, chi-square value, the calculation for the chi-square. So these are all the digits here from the table. These are all the digits 0 till 9, and these are all the frequency tables, and we have to fill it in the second column. So the total here is 10,000. So the value here is the 10,000 value. And the next one here, what we have to do, so this is the expected value, that is 1,000. So we have to make a subtraction, that is 1,026 minus 1,000 is nothing but, see here, 26. So the value here is 26. So here the difference here is 26, and if I make a square, this is 626. Clear? So the difference here is 1107 minus 1,000 is 107, the difference, and if you make a square, the value here is this one. So we have to make a subtraction and again square. So this will be the column here and divided by. So this column is, after making this one, 676 divided by the expected value, that is 1,000, which is equal to 0.767. That is here 11,449 divided by 1,000. This is 11.449. So we have to fill this column like this, and we have to make an addition. So after making an addition, the value here is 58.572. Clear? So this is our chi-square. The calculated value here is 58.542. And now here the number n is equal to 10. So for n, the degrees of freedom is n minus 1. The 10 minus 1, the value here is 9. So for chi-square test at 9 degrees of freedom at 5% level, see here at 5% level, the value here is, this is the tabular value, at 9 at 9 the degrees of freedom, at 0.05, that is 5% level of significance, that is 16.619. So here from the tabular value here is a 16.919. On comparing the calculated value and the tabular value, clearly this value is far greater than the tabular value. And see here, the calculated value is greater than the tabular value, and therefore we are going to reject the null hypothesis. We reject the null hypothesis H naught, and therefore what is the conclusion part? The conclusion that the digits do not occur equally in the directory. So here is the conclusion that the digits do not occur equally frequently in the directory. And here is the fourth question here. A die is thrown 264 times with the following results. Show that the die is biased. So here a degrees of freedom chi-square, that is 11.07 at 5 degrees of freedom. So here this is the table given. So as usual we have to go with the null hypothesis. The die is unbiased. The expected frequency here is 264. See here, this is 264 divided by, a die has a 6 numbers, divided by 6, the value here is 44. And therefore the observed values here from the table is, the observed values is 40, 32, 28, 58, 54 and 52. So we have to fill it in the first column. So here the total is 264. So this value is 264, and these are all the expected values, that is 44. And next one we have to subtract 40 minus 44 whole square. This is 4 square, which is equal to 16. 32 minus 44, 32, 8, 12. 12 square, that is 144. And we have to make a subtraction out of this, and we have to make a square. So here there is square given. And next one divided by E. E is expected value, that is 16 divided by 44, that is 0.3636. 144 divided by 44 is 3.2727. Like that we have to fill this column, and this is the summation of OI minus EI whole square by EI. So we got the chi-square value as a 17.6362. And here the degrees of freedom n minus 1. So as there are in how many values? 1, 2, 3, 4, 5, 6. 6 minus 1, 5 values. And at 5% level of degree. So so in the question itself they have given, that is 11.07. So here the tabular value is 11.07, and this value is nothing but the calculated value. As the calculated value is greater than, so it is very clear that the calculated value chi-square is greater than the tabular value, and therefore we are going to reject the null hypothesis H naught. And after rejecting the null hypothesis, we reject the hypothesis that the die is unbiased. So hence the die is biased, and this is the result. And this is how we have to check with chi-square test of goodness, as the expected value and the observed values are given. So we have to calculate the expected value, so which is nothing but the mean average. And the next one here is 20 digits were chosen at random from a set of table. The frequency of the digits are shown below. So these are the digits and these are the frequency values. Use chi-square test of goodness. They'll be asking use chi-square test of goodness to access the correctness of the hypothesis that the digits were distributed equal number in the table from which these were chosen. So the first one is the null hypothesis as usual. The digits were distributed in an equal number in the tables. See here from the table here, so these are all the values 18, 19, 23, 21, 16, 25, 22, 20, 21 and 15. So we have to fill it in the first column. So after making an addition, the value here is 200. So this value is 200. What is the expected frequency? That is 200 divided by the number of values. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 200 by 10, the value here is 20. The expected frequency of each digit is 20, and therefore we have to make a subtraction and we have to square up it. That is 18 minus 20, which is equal to minus 2 whole square. This is equal to 4. 19 minus 20, minus 1 whole square. This is plus 1. 23 minus 20. 3 square, this is 9. 21 minus 21 square, this is 1. So we have to fill this column, and this column will be 4 divided by expected value 20. The value is 0.2. 1 divided by 20 and 9 divided by 20 is this one. So we have to make an addition, that is 4.3. The value here is 4.3. And therefore the chi-square formula here is a sigma. See here, that is a sigma OI minus EI whole square by EI, the value here is 4.3. The calculated value of chi square is 4.3. See here, for degrees of freedom, 10 minus 1, 9 degrees of freedom at 5% level from the table here. So I'll show you the chi square table here. 9 degrees of freedom, so we have to go with 9 and we have to check, that is 16.919. So here from the table it is 16.919. This is the calculated value. As the calculated value is smaller than the tabular value, the calculated value is less than the tabular value, and therefore we are going to accept the null hypothesis. So here the digits are distributed in equal. The digits are distributed in equal number in the table, and this is how we have to solve. And this is chi-square test of goodness. These are 5 problems today in this video, and in my upcoming video I'm going to post a few problems which are also very important. The model method is so simple to follow, and this is the damn sure question. Each question is so easy to solve, and definitely you can score more if you get in the examination. And if you really like, you know what to do, please share it with the one who need the most. And thank you so much for watching and staying till the end. You know what to do. If you really like, please raise your thumb, pass it on to your friends, and subscribe to this channel.